past paper question 4. This is the last past paper question that we're going to look at in this section of quadratics. It says a rectangular picture measuring 9 centimeters by 13 centimeters is placed on a rectangular piece of card. The area of the card is 270 square centimeters. There is a border which is X centimeters wide on all sides of the picture. So I want to write down an expression for the length of the card in terms of X. Okay? So the length of the card is made up of the 13 that's here plus the value of X here plus the other value of X on that side. So a simple expression for the length is, I can say that length is equal to 13 plus 2x. It's as simple as that. Hence show that 4x squared plus 44x minus 153 is equal to 0. Okay, so this involves me making up a new quadratic. This question is talking about the area of the piece of card. Okay, so if I want to make this quadratic equation appear, I have to consider the area of the card. So the length is 13 plus 2x. The breadth is going to be 9 from here to here, plus a value of x here, plus a value of x here. So I can say that the breadth is equal to 9 plus 2x. The question says that when you find the area, that is equal to 270 square centimeters. So let's use the length and breadth together to find the area, make it equal to that, and then hopefully that will allow us to make this appear. Okay? So for room, I'm going to do it up here. So area is equal to length times breadth. So that's going to be 13 plus 2x times 9 plus 2x. And we know that that is equal to 270. Expand the brackets. So 9 times 13 is going to give me 107. It's looking good already. Plus 18x plus 26x plus 4x squared is equal to 270. Take the 270 across, so that gives me 4x squared. 18x plus 26x is going to give me 44x. And then I have 107. Take the 270 across, I minus it. So 107 take away 270 is going to give me my minus 153 equals 0, as required. So remember, the whole purpose of this question is to try and get you to tease out the information. It's worth 2 marks. Don't worry too much if you don't get that. It is quite a big leap reading the question, but at least you can still use that to answer part B, where it says calculate x, which is the width of the border. Now, this question is saying give your answer correct to 1 decimal place. The clue here, this is actually telling us to use the quadratic formula, because we can't get roots to 1 decimal place rounded by factorising. We have to use the quadratic formula, and it is quite a big number here as well. So there's no way we could possibly factorise that. So let's use the quadratic formula. Let's write down our values of a, b, and c first of all. So a is equal to 4, b is equal to 44, c is equal to minus 153. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to minus 44 plus or minus the square root of 44 squared minus 4 times 4 times minus 153 all over 2 times 4. Okay, so let's work this out in the calculator then. So that'll be minus 44 plus or minus, so then we have 44 squared minus 4 times 4 times minus 153, which will give me 4,384 all over 8. So x is equal to minus 44 plus the square root of 4384 over 8, or minus 44 minus the square root of 4384 all over 8. So that will be minus 44 plus the square root of 4384. Press equals, then divide by 8, and we get 2.7765. Or, and it's minus 44 minus the square root of 4384, press equals, divide by 8, and it's minus 13.776. It wants it to one decimal place, so we can say therefore x is approximately equal to 2.8 or minus 13.8. Now, again, it said calculate x, which is the width of the border. You should always be aware that when it's a real life situation, you should always consider the answers that you get at the end. So, the answers I've got here are 2.8 and minus 13.8. We can't have a negative length, so we are just going to discard that. So, finish off by fully saying, therefore, x is approximately equal to 2.8 centimetres. And that's our answer. Okay.